Hello class, so this will be our module 6, moments of inertia. So in this module, we will deal with area, moment of inertia. So it is essential in structural design. So many engineering formulas such as those being used in the analysis and design of beams and columns involve the use of the moment of inertia. So sa mga advanced subjects nyo like strength of materials, structural analysis, and sa mga design subject ninyo, so very useful yung ating moments of inertia. So it is denoted by the symbol I. Okay, so it is moment of inertia are determined by integration. So with respect to if we have a body of a material here and meron tayong differential area. So by definition, the moments of inertia of a differential area, ito, dA, about x and y axis is equal to sa integral nung ating so for x, ix natin, so yung ix natin will be the integral of y squared times dA. Okay? So kung ito yung dA natin, no? So i-multiply natin siya kung respect with the x-axis tayo, no? With respect to the x-axis tayo. So that will be dA multiplied by yung twice nung ating or yung squared nung ating perpendicular distance, which is yung y. Okay? So ganon din for the IY. So ang perpendicular distance niya is yung x squared and times yung differential area natin. Okay? So the moment of inertia of area is sometimes called the second moment of area because each differential area multiplied by its moment arm gives the moment of area. So kapag yung differential area is minultiply natin sa moment arm niya, example with respect to y-axis, so yung moment arm niya is x, so it gives the moment of area. So yung moment of inertia naman is i-multiply ulit natin siya second time but by its moment arm. Kaya naging x squared yon. Okay? It will give the moment of inertia. And we have the called polar moment of inertia. So the moment of inertia for an area relative to a line or axis perpendicular to the plane of the area is called the polar moment of inertia and is denoted by the symbol J. So yung polar moment of inertia natin is denoted by Jz. So that is equal to Ix plus Iy. No? So sabi niya dito, yung moment of inertia of an area relative to a line or axis perpendicular to the plane. So meron tayong plane dito. So example, if we have a plane here, so dapat perpendicular to the plane. So ito yung z natin, no? This is perpendicular dun sa ating plane na x and y, no? So ibig sabihin yung perpendicular distance, so ito yung magiging perpendicular distance natin. Okay? So ito yung dA natin. So kapag naka-top view tayo, di ba? So if we are top view, so ito yung dA natin. Okay? This will be our so x and y axis tayo. So ito yung magiging y natin and this will be our x. And let's call this z. So yung z natin will be equal siya sa z is equal to, so yung z squared, Pythagorean theorem lang, that will be x squared plus y squared. And yung jz natin, sabi niya na, kaya nakuha yung ix plus iy. So yung jz natin is equal to the integral of z squared times yung the differential area natin, which is yung z squared natin is equal to, so that will be jz is equal to integral of, so substitute lang natin x squared plus y squared dA. Or equal din siya sa integral ng x squared times dA plus y squared, integral ng y squared times differential area. So that is equivalent to jz is equal to, so this is ix, so this is iy plus ix. Okay, so yun yung derivation ng ating polar moment of inertia. And we have the radius of gyration. So the term radius of gyration is used to describe another mathematical expression and appears most frequently in column formulas. So it is denoted by the symbol small letter r. So yung radius of gyration natin, that is equivalent lang sa I over a. Okay, square root of I over a, whereas I is the moment of inertia and a is the cross-sectional area. Okay, and we have the transfer formula for moment of inertia. So it is often necessary to transfer the moment of inertia from one axis to another parallel axis. So the transfer formula affords a method of doing this without further integration. So for Ix, with the moment of inertia with respect to the x, so that will be Ix plus AD squared, which is yung area natin, is yung differential area natin, is yung area ng material natin times yung D. Okay? So this equation state that for any area the moment of inertia with respect to any axis in the plane of the area is equal to the moment of inertia with respect to a parallel centroidal axis plus a transfer term composed of the product of the area multiplied by the square of the distance between the axis. So ito yung distance natin, no? Yung square nung distance niya between the axis. Okay? So meron tayong mga moments of inertia for composite areas. So yun yung makikita sa ating table 7-6.1 and table 7-6.2. Okay? So ito yung sa moment of inertia ng ating mga common sections. So for rectangle, so moment of inertia Ix will be bh cube over 12. Okay, and this is yung radius of gyration niya. That will be h over square root of 12. And for triangle, moment of inertia will be bh cube over 36. And for circle, that will be pi r raised to 4 over 4. Okay, and yan, tingnan nyo na lang dito. So andito yung mga moment of inertia ng semicircle, quarter circle, ellipse, spandrel, and we have the properties of structural sections. So given yung moment of inertia niya, so Ix and Iy, and given din yung kanyang bar x and bar y, which is yung centroid ng ating mga materials. Okay, so you can refer this sa table sa ating mga example na problems. Okay, so for rectangle, bh cube over 12, triangle, bh cube over 36, and circle, pi r 4 over 4. So mga basic lang na shape ito para ma-determine natin ang moment of inertia. Okay, so example tayo. So the following examples are shown to illustrate how to determine the moments of inertia and products of inertia of composite areas and build-up sections. So for example number 1, the shaded area shown as an area of 5 inch squared and a moment of inertia of 30 inch raised to 4. About axis x, 1. Find the moment of inertia about axis x, 2. Okay? So area natin is 5 inch squared and yung Ix1 natin that will be equal to 30 inch raised to 4. So yung Ix1 natin, no? So yung Ix with respect to Ix1 is equal to Ixo plus AD squared. Okay? So yung Ixo natin with respect to Ixo, so kailangan natin kunin yung Ixo natin. So given yung moment of inertia natin about x1, so that is 30 inch force is equal to Ixo plus yung area natin that is 5 inch squared. So yung distance natin with respect to x1 with the Ixo, so that is 2 inch. Okay, so that will be 2 raised to 2. So computing for Ixo, makukuha natin yung Ixo, so that will be equal to so shift solve na lang tayo dito, so that will be equal to 10 inch raised to 4. Okay, so solving for moment of inertia about axis x2, so for moment of inertia about axis x2, so that will be Ix2 is equal to Ixo plus AD squared. So that will be moment of inertia with respect to x2 or Ix2, that will be is equal to yung Ixo natin is 10 inch raised to 4 plus area natin is 5 inch squared times yung distance na gagamitin natin is, so for with respect to Ix2, so 3 inch yung gagamitin naman natin ngayon, so that will be 3 squared. So moment of inertia with respect to x2, that will be equal to 55 inch raised to 4. Okay. So next example tayo. So determine the moment of inertia of the T section shown in the figure about its centroidal XO axis. Also compute the radius of gyration of the area with respect to the XO axis. So kunin natin yung moment of inertia with respect dun sa kanyang centroidal axis. So yung centroidal axis niya is nandito. Okay? So here, ito yung centroidal axis niya. So kailangan muna natin kunin yung bar y niya, no, before natin makuha yung kanyang moment of inertia. So yung bar y niya will be dito tayo sa baba mag-reference. So ito yung bar y niya, no. So ito. Okay. So first na gagawin natin is kunin natin yung kanyang bar y muna. So, gagawin natin is kunin muna natin yung XO axis niya. Yung centroidal XO axis niya. So, katulad lang ng ginagawa natin dun sa Module 5 sa pagkuha ng centroid. So, we can divide it into two parts. So, we can have two parts here. Two rectangular. So, ganun lang ulit. So, let's solve it. So, part. So, first part natin will be yung nasa taas. So, that will be rectangular. First, this is our first part. And second part is yung naka-vertical na rectangle. Okay? So, first is yung area. So, yung area ng first part natin, that will be equal to 6 times 2. So, that will be 12. So, for the second part, so ganun din, 6 times 2. So, that will be 12 din. No? And yung total area natin will be 24. Okay? And for the y nung individual section natin, so yung magiging reference muna natin is dito sa baba. So, para makuha natin yung bar y. And yun yung location ng ating XO axis or yung centroidal axis niya. So, for y ng individual parts, so yung nasa taas muna, first part, so that will be 6 inch plus, so dito sa gitna yung kanyang centroid, so that will be 6 plus 1, no? So yung gitna lang, that will be 2 divided by 2, so 1, so that will be 6 plus 1, so 7. And for the second part, so dito yung centroid niya, no? So yung magiging distance nito will be 6 divided by 2, so that will be 3. Okay. And for AY, so we can now get the AY. So for AY, that will be 12 times 7, that will be 84. 12 times 3, that will be 36. Okay. And yung summation ng AY natin, so summation ng AY natin, that will be equal to 120. So computing for bar Y, so that will be bar Y is equal to summation of AY over total area, so that will be 120 over 24. Therefore, yung bar Y natin is equal to 5 inches. Okay? So, yung bar Y pala natin, so this is equal to 5 inches. So, para mas clear, gamitin natin yung red. So, this is equal to 5 inches. Okay? So, alam na natin yung location ng centroidal XO axis natin. Makakompute na natin yung moment of inertia natin. So, first is kunin muna natin yung moment of inertia ng bawat parts. Okay? So, IX. So, naka-inch raised to 4 ito, no? So, for IX nung ating rectangular dun sa ating sa taas, so that will be BH cube over 12. So, yung base natin will be 6 inches and yung H natin will be 2 inches, no? So, take note of the orientation class, no? So, dito yung reference natin with respect to XO. So, for IX will be base will be 6 and H will be 2. So, that will be 1 over 12 times yung B, which is 6 inches times 2. Okay? So, that will be equal to 4. And for the isa pang rectangle, so that will be 1 over 12 times yung base natin will be 2 and yung magiging height natin, BH cube, height natin will be 6. Okay? So, this is raised to 3 class, No, raised to 3. So, that will be equal to 36. No? So, yung total natin, no? So, for the total ng IX natin, so that will be 36 plus 4, that will be 40. Okay? And yung D natin, no? So, dahil yung magiging formula natin dito is yung moment of inertia nung T section with respect to dun sa XO is equal to summation nung I, nung X natin, ay nung mga sections natin, ng dalawang rectangular, plus summation din nung ating A D squared. Okay? So, idagdag natin yung D tsaka A D squared dito. No? So, yung D natin and yung A D squared. So, yung D natin for D1, so ito yung D1 natin. No? This is our D1 and this will be our D2. Yung distance nung kanyang, so for D is yung distance nung centroid nung ating material, yung parts, with respect doon sa ating XO. Okay? So yung distance centroid to the centroidal XO axis. Okay? So D1, paano natin kukunin yung D1? So that will be 5 inch. Yung total distance nito, 7. So, 7 minus 5. So, matitira, this will be equivalent to 2. Okay? So, this will be 2. And for the D2 naman, so that will be 5 inch. So, 5 inch minus yung ating 3, yung distance nito. So, this is 3. So, yung matitira na lang doon is 2 din. Okay? So, the same lang sila na 2. Therefore, yung AD squared natin, so i-multiply lang natin yung area. So this is 12. That will be 12 times yung d natin is 2. So 2 squared. So that will be 12 times 4. That will be equal to 48. So this will be equivalent to 48. So same lang din, magiging 48 din to. So yung total na AD squared natin is 96. Okay. Now we can get na yung kanyang moment of inertia. So getting the moment of inertia, so that will be moment of inertia ng t section with respect to x o or yung centroidal axis is equal to summation ng ating ix sa ating individual na parts or sections plus summation ng ating a d squared. So moment of inertia with respect to centroidal axis ng ating t section, so that will be equal to, so summation lang natin. So summation ng ix natin will be 40. So that will be 40 plus summation ng AD squared natin. So that will be 96. Okay. Plus 96. So IXO natin will be equal to 136 inch raised to the 4th. Okay. So ito na yung IXO natin. And for the radius of gyration, so sabi natin R is equal to the square root of I over A. So R, yung I natin will be with respect to the XO, no? So sabi niya doon, radius of gyration with respect to the XO axis. So isa-substitute lang natin, so that will be the square root of 136 inch raised to the 4th over ano yung area natin, that will be 24. Okay, so that will be 24. So R is equal to, so radius of gyration will be 2.38 inch. Okay, so ito na yung radius of gyration natin. So next example naman tayo. Find the moment of inertia about the indicated y-axis for the shaded area shown. So meron naman tayong shaded area dito. So we can solve for the moment of inertia by dividing it into 3 geometric shapes, no? So we have triangle, square, no? So ito yung magiging square natin. And we have the quarter circle. Okay? So the quarter circle has a negative area since it is not part of the shaded area. So parang ganoon din kanina yung yung sa pagkuha natin ng centroidal axis. So kapag hindi siya shaded at isasama natin siya sa ating computation, it will have a negative sign. Okay? So divide ulit natin into 3 parts. So table ulit, no, para mas madali. So parts. So first is yung ating triangle. Second will be yung ating square and yung quarter circle natin. Okay? So compute natin yung area ng bawat shape. So area ng bawat shape natin. So we have a triangle. So 4 inch yung kanyang height, 6 yung base. So that will be 1/2 6 times 4. So that will be equal to 12. And rectangle natin, that will be 4 times 4, that will be 16. And yung for the quarter circle natin, so quarter circle natin, so that will be negative siya, pi over 4 times 4 squared. Okay? So that is equal to negative 12.57. Okay? So yung area ng circle natin, di ba, class, is pi r squared. So i-divide natin ng 4, yun na yung area ng ating quarter circle, di ba? So that will be negative 12.57. Ngayon, kunin naman natin yung kanyang I. So, kunin na natin yung moment of inertia ng bawat parts para makuha natin yung kanyang moment of inertia ng buong ating figure with respect dun sa ating y-axis. So, yung kukunin natin will be with respect to the y-axis. So, y is equal to, so for this one, BH cube over 36. So, yung base natin is magiging 4 inch and yung height natin will be 6. Okay? So, with respect to x-axis class, y-axis, no? With respect to this y-axis. Kaya kapag y-axis, yung gagamitin natin is IY. So, yung IY nung ating triangle. So, check natin yung moment of inertia. So, check natin. So, for any triangle, that will be BH cube over 36. So, this is respect with x, no? So, with respect to x, yung base niya is along x-axis. Okay? So, for this one, yung base natin, with this IY yung kukunin natin, no? So, with respect to y, so yung base natin is along y. So, yung 4 inch yung magiging base natin dito. Okay? So, that will be 1 over 36 times. Yung base natin will be 4 and yung height natin is 6. So, yung 6 yung kakaroon ng raised to 3. Okay? So, that will be equal to 24. And for the rectangular, so that will be BH cube over, that will be BH cube over 12. So, that will be 1 over 12. So, kahit saan na, parehas din naman, square naman siya. So, that will be 4 times 4 raised to 3 is equal to 21.33. And for the for the quarter circle, so ano yung moment of inertia ng quarter circle natin? So for the quarter circle, so that will be Ix equal to Iy. So same lang din siya. That will be pi r raised to 4 over 16 or 0.055 r raised to 4. Okay. So i-substitute na lang natin. So that will be equal to 0.055. Ano yung r natin? Will be 4 raised to 4. So that will be equal to, so negative siya class. So negative 14.08. Okay. So kunin natin yung summation niya. So yung summation ng IY natin, so pagpalasin na lang natin tong tatlo. So that will be 31.25. And for the D, so let's compute for the D. So yung for the D is yung centroid ng bawat shape with respect dun sa ating Y axis. Okay? So yung centroid ng ating triangle is dito banda. So yung magiging so yung distance natin from y-axis, so sabi natin centroid ng triangle is 1/3 ng 6. So yung distance na ito will be 1/3 ng 6. So that will be 2. So 6 minus 2, that will be, this will be now 4. So yung sa triangle, that will be 4. And for the rectangle, so yung tangle is gitna, no? So nasa gitna. Nasa gitna yung magiging centroid niya. So distance from the y axis, so yung magiging distance nito from the y axis, so that will be 6 plus, so yung gitna lang ng 4 inch, that will be 2. So 6 plus 2 is 8. And for the semicircle, So for the semicircle, that will be equal to, so yung tingnan ulit natin yung centroid ng semicircle. So for the semicircle, quarter circle, so that will be 0.424 r. Okay? So 0.424 r. So yung 0.424 r natin is dito banda, no? So yung 0.424 r natin is ito. Okay? So this is 0.424 r. So yung magiging d natin, so yung d natin will be ito na. Yung distance nito hanggang dun sa y-axis natin. So that will be 6 plus 4, so 10, no? So 6 plus 4 is equal to 10. I-minus natin yung 0.2424. So that will be 10 minus 0.424 r, which is yung r natin is 4 inch. So 10 minus 0.424 r, so that will be 8.304. Okay. So kunin naman natin yung AD squared niya. So AD squared. So multiply lang natin area times yung D squared. So 12 times 4 times 4. So that will be 192. And then 16 times 8 times 8. So that will be 1024. And this will be negative 12.57 times 8.304. So negative siya class. So that will be negative 866.78. Therefore, yung summation ng ating AD squared, so summation ng ating AD squared is equal to 349.22. Okay? So that is equal to 349.22. So therefore, yung moment of inertia natin about dun sa y-axis. So yung moment of inertia with respect to y-axis is equal to, so summation ng I nung kanya ating mga parts. So summation ng IY natin plus summation ng ating AD squared. So summation ng ating AD squared. So that will be equal to, summation ng IY natin is 31.25 plus AD squared is 349.22. Therefore, yung IY natin is equal to 380.47 inch raised to the 4th. Okay? So this will be our final answer.